Consequences of increased atmospheric CO2 and strategies to reduce emissions and enhance the carbon cycle. The continuous rise of atmospheric carbon dioxide or CO2 has become one of the most pressing environmental issues of our time. Human activities, particularly the burning of fossil fuels, deforestation, and industrial processes, have significantly accelerated CO2 accumulation in the atmosphere. As a result, the natural balance of the carbon cycle is being disrupted, posing serious consequences for ecosystems, human life, and the planet's overall stability. Understanding these effects is essential in developing effective strategies to reduce emissions and strengthen the natural processes that regulate carbon. One of the most critical consequences of increased atmospheric CO2 is global warming. CO2 is a greenhouse gas, which means it traps heat in the atmosphere. When its concentration rises, more heat becomes trapped, leading to an enhanced greenhouse effect. This contributes to rising global temperatures and fuels climate change, which is reflected in more frequent heat waves, shifting weather patterns, stronger typhoons, and prolonged droughts. These changes threaten food, production, water resources, and human health. Another major impact is ocean acidification. Since the oceans absorb a large portion of excess CO2, the interaction forms carbonic acid, lowering the ocean's pH. Acidic waters harm marine organisms such as corals, shellfish, and plankton, disrupting entire food chains and weakening coastal ecosystems. Increasing CO2 levels also affect terrestrial ecosystems. As temperatures rise, many species are forced to migrate to new habitats or face the risk of extinction. Forests become more vulnerable to wildfires, pests, and diseases, reducing their ability to store carbon. The impacts of climate change extend to human communities as well. Rising sea levels endanger coastal populations, while agricultural yields may decline due to unpredictable climate conditions. These consequences reveal that the effects of rising CO2 are not isolated environmental issues but interconnected threats to global stability. One of the most effective approaches is transitioning from fossil fuels to renewable energy sources such as solar, wind, and hydropower. These alternatives generate electricity without producing CO2, making them crucial in lowering global carbon footprints. Improving energy efficiency is another important strategy. Using energy efficient appliances, improving building designs, and adopting cleaner industrial technologies help reduce unnecessary energy consumption and emissions. Additionally, promoting sustainable transportation, such as public transit, cycling, walking, and electric vehicles, can significantly reduce emissions from one of the largest contributing sectors. Beyond reducing emissions, enhancing the natural carbon cycle is equally important. Reforestation and afforestation efforts increase the number of trees capable of absorbing CO2 from the atmosphere. Protecting ecosystems like wetlands, mangroves, and grasslands is also vital since these environments serve as natural carbon sinks. Sustainable agricultural practices, including crop rotation, organic farming, and reduced tillage, improve soil health and increase its capacity to store carbon. Emerging technologies such as carbon capture and storage also offer innovative solutions to directly remove CO2 from the atmosphere or prevent its release from industrial sources. In conclusion, the rise in atmospheric CO2 brings significant consequences that affect the climate, ecosystems, and human life. However, by adopting renewable energy, improving efficiency, protecting natural ecosystems, and restoring vital carbon sinks, societies can reduce emissions and support the natural processes that regulate carbon on Earth. Addressing this issue requires global cooperation and responsible environmental stewardship, ensuring a healthier and more resilient planet for our future generations.